Welcome to the EPA 608 Universal Course. EPA 608 Universal Certification include Type 1, Type 2, and Type 3 certification. Ready to take the EPA Universal exam? For the instruction in the video. To take the EPA exam and to get EPA certificate, you must download the SkillKit mobile application. We can only protect via the SkillKit mobile app. Download it, and by the end of the course, you should be able to explain basic refrigerant concept to identify key EPA 608 regulation 3, discuss refrigerant handling procedures in a small and low pressure and high pressure appliances. Received your EPA certificate. Okay, let's start. This the study guide.
The EPA Section 608 certification is essential for
Let's
anyone.
start from beginning.
In this study guide, we'll introduce the EPA Section 608 certification and discuss the best study approach for learning the course.
The EPA Section 608 certification is essential for anyone involved in servicing, maintaining, or disposing equipment that could release refrigerants into the atmosphere. This certification is critical due to its role in environmental protection, specifically concerning ozone layer depletion and global warming. EPA Section 608 is divided into 4 distinct sections. EPA Core, Type 1, Type 2, and Type 3. Each section caters to different types of appliances and their corresponding service requirements. EPA Core covers fundamental principles applicable to all types of equipment, including environmental impacts, regulations, refrigerants, and safety procedures. EPA Type 1 focuses on the regulations, recovery techniques, and servicing requirements of small appliances with less than 5 pounds of refrigerant. EPA Type 2 pertains to high-pressure and very high-pressure appliances, with the exception of small appliances and motor vehicle air conditioning (MVAC) systems. EPA Type 3 focuses on low-pressure systems with an emphasis on unique aspects like water-cooled condensers and different leak detection methods. EPA Type 2 and Type 3 share several similarities. Both sections emphasize the importance of detecting and repairing leaks, reflecting shared environmental and safety concerns. Some leak identification and repair methods may appear identical as a result. Both sections also stress the critical safety protocols and equipment used to prevent accidents and ensure technician safety. Expect to encounter a couple of similar protocols and even equipment, as most of these systems operate under the same principles. Since the core knowledge applies to all sections, start with mastering this part. It provides the groundwork on which the other sections build. Focus on topics like the Clean Air Act, refrigeration cycles, and safety standards. Identify how each section's specifics relate back to the core principles. For example, you can focus on how the refrigeration cycle components vary across different types of equipment, or how safety precautions may differ. Regularly review each section and test your understanding with practice exams or quizzes. Focus on areas of weakness and ensure you understand both the how and the why behind each concept.
Okay, this is a study guide. Let's start with introduction.
In this introductory module, we will start by taking an overview look of the exam. We will take a look at who should take the EPA 608 exam and what each EPA certification.
EPA stands for Environmental Protection Agency. It is the U.S. federal agency responsible for implementing laws and regulations passed by Congress. As you can tell from its name, the EPA focuses on environmental protection. The purpose of EPA Section 608 is to regulate substances that are harmful to the environment. As HVAC technicians, this is relevant to us because the cooling equipment we work with contain these harmful substances. In order to service or dispose of appliances containing regulated substances, technicians must pass the EPA 608 exam. For example, refrigerant chemicals used in refrigerators or air conditioning systems may fall into this category of regulated substances. We will discuss what these chemicals are in a later module. If you are a standard HVAC tech, it is likely that you will need EPA 608 certification. Even if you are in charge of only disposing of refrigeration equipment, you may still require certification. In later modules, we will take a closer look at who needs EPA 608 certification. The law is subject to change even after you receive your EPA certification. It is your responsibility to keep up with changes in the law regarding these restricted substances. The EPA may update regulations to make them more strict. You will need to make sure you are in compliance with all appropriate federal, state, and local laws.
Question: once you pass the EPA exam, the regulation you learned will never change. This is false. Correct. As environmental technicians, we must be up to date with which types of law, federal law or state law or local law, all types of law.
There are 4
Submit.
types of EPA
Correct.
608 certification. All types of EPA certification include EPA Core, which comprises essential content necessary for all certifications. The type of certification that you will need depends on what types of systems you will be working on. At SkillCat, we offer all 4 types. The 4 types of certification are Type 1 certification, Type 2 certification, Type 3 certification, and Universal certification. We will go over each of these briefly so you can get a sense of which one is right for you. All EPA certifications contain 25 questions from EPA Core and 25 questions for each specific certification. For example, if I want Type 1 certification, there will be 25 questions on the content on EPA Core and 25 questions on Type 1 specific content.
If you need to get Type 3 certification, which of the following will be on your exam? 50 question, 25 core question, and 25 in Type 3 question, or 25 Type 1, 25 Type 3 question, 25 core question. It is the correct answer. It's 50.
Type 1
Correct.
certification is needed if you are servicing small appliances that contain restricted substances. Small appliances are defined as appliances containing 5 pounds of refrigerant or less. An example of a small appliance would be a household refrigerator or freezer. Type 2 certification is needed if you are servicing high-pressure or very high-pressure appliances that contain restricted substances. Type 2 excludes small appliances in MVAC systems, which are in motor vehicles. An example of a Type 2 system is a rooftop unit or a residential air conditioning system. Type 3 certification is needed if you are servicing low-pressure appliances that contain restricted substances. These include commercial cooling systems such as the air conditioning systems used in office buildings. Last but not least, universal certification contains all of the different types of EPA exams. As such, universal certification would include EPA Core, EPA Type 1, EPA Type 2, and EPA Type 3.
How many questions will you receive for universal certification? We will receive 100 questions.
The passing grade for all
Correct.
certifications is 70%. Once you pass the test, you retain your EPA certification for life.
What is the passing grade for all EPA certifications? It will be
We
70.
use a virtual proctoring service
Correct.
in compliance with EPA requirements. Your EPA 608 exam will be 100% virtual. Once you pass your EPA 608 exam, you will receive the option to download your EPA certification. Please make sure to keep this with you at all times when you are servicing equipment. If you lose your certification card, your certifying organization will provide a replacement. In this case, that would be us, SkillCat. Now that you get a sense of what the EPA 608 certification is like, let's jump right into EPA Core.
Now we will start EPA Core. Let's finish the quiz at first. Okay, the quiz we finished and it is 100%. Let's go to the core. This is the first one, is the core, the ozone layer.
In this module, we will introduce the ozone layer and talk about how it is essential to life on Earth.
An atom is the basic building block of all matter. Ozone is a naturally occurring gas made up of 3 oxygen atoms bonded together. Earth's atmosphere is made up of several layers, as shown. Ozone gas is found in the 2 lowest layers of Earth's atmosphere, the stratosphere and the troposphere.
Most ozone is found in the upper atmosphere, where it is produced in small amounts, when the sun's high-energy rays strike ordinary oxygen molecules.
Ozone had 3 atoms of oxygen.
An oxygen molecule is made up of 2 atoms. In the atmosphere, the sun's high-energy rays break the bond between the 2 atoms. Each free atom then bonds with other pairs to form ozone molecules. Stratosphere and troposphere. The highest concentration of ozone is found in the stratosphere. The dense ozone found in this region is what we refer to as the ozone layer. The sun emits high levels of ultraviolet radiation, which is harmful to humans. The ozone layer protects us from these harmful rays by absorbing and reflecting the radiation before it reaches the Earth's surface. Most of the sun's ultraviolet rays don't make it past the stratosphere. Ozone can also be found in the lowest layer of the atmosphere, the troposphere. When it's this close to ground level, it is mainly in the form of smog. Smog is a type of ozone created by chemical reactions between pollutant emissions and sunlight. Smog is considered a harmful pollutant because of its effects on humans and the environment. In high concentrations, it can cause respiratory damage when inhaled and destroy plant life by restricting photosynthesis. To summarize, there are two types of ozone. Stratospheric ozone. This ozone performs the essential function of absorbing and reflecting harmful UV rays from the sun. Ground-level ozone. This ozone is generated from pollution and is harmful to humans' health.
What is the function of ozone in the stratosphere? Absorb and reflect UV rays from the sun. Yeah. Create UV ray, direct UV rays, convert, submit. It's correct. Ozone is essential to life on Earth because it absorbs and reflects harmful UV ultraviolet rays from the sun. Ground level ozone is what absorbed and reflected harmful UV rays from the sun. Ground level ozone is what absorb and reflect harmful UV. False. The statement is false. Ozone is the stratosphere absorbs and reflects harmful UV rays from the sun, not ground level ozone. Most of ozone in the atmosphere is located in the troposphere. I think it's false. Statement is false. Most of ozone in the atmosphere is located in the stratosphere,
In
not
conclusion,
in troposphere.
ozone occurs naturally in the stratosphere and troposphere, with the highest concentration found in the stratosphere. It is essential to life on Earth because it absorbs and reflects harmful UV rays from the sun.
Okay, this is the ozone layer. This is the second one, ozone depletion. In this module, we will discuss how chemicals used in a refrigeration system destroys the ozone layer. We will also take a look at the effect of ozone
In the 1970s,
depletion.
scientific research discovered that some human-produced chemicals were destroying the ozone layer.
Ozone molecules in the upper atmosphere absorb most of the sun's harmful ultraviolet rays before they reach the Earth. These rays can cause skin cancer and other health problems. A group of gases called chlorofluorocarbons, or CFCs, may pose a threat to the ozone layer. Chlorofluorocarbons are chemical compounds made up of atoms of chlorine, fluorine, and carbon. CFCs are used as refrigerants and to make plastic foam insulation. Because they are gases, CFCs can escape from poorly sealed containers into the atmosphere. Once CFCs are in the upper atmosphere, scientists believe a chain of reactions occur that destroy ozone. First, high-energy ultraviolet rays break chlorine atoms free from the CFC molecule. These free chlorine atoms can react with other molecules in the atmosphere. When a chlorine atom reacts with an ozone molecule, it steals one of the ozone molecule's 3 oxygen atoms, forming a molecule of chlorine monoxide. The remaining 2 oxygen atoms form an ordinary oxygen molecule. In this way, an ozone molecule is destroyed. Chlorine monoxide reacts easily with single oxygen atoms in the atmosphere, leaving a free chlorine atom that can destroy more ozone. Scientists estimate that 1 chlorine atom can destroy as many as 100,000 ozone molecules.
As mentioned in the video, the main chemicals at fault for this destruction are CFCs, which stand for chlorofluorocarbons, and HCFCs, which stand for hydrochlorofluorocarbons. CFCs and HCFCs are categories of refrigerants. They were once used in almost every refrigeration and AC unit before it was discovered that they were destroying the ozone layer. The most harmful refrigerants in terms of ozone depletion are CFCs. This is because there are more chlorine molecules in CFCs than HCFCs. When CFCs and HCFCs reach the atmosphere, UV radiation breaks their bonds to release their chlorine atoms. These free chlorine atoms bond easily with one of the oxygen atoms in the ozone molecule, and in the process, break apart the ozone molecule. Each chlorine atom destroys an ozone molecule as it binds with one of its oxygen atoms to form chlorine monoxide and oxygen. The chlorine monoxide molecule moves around the atmosphere, colliding with more oxygen atoms. Single oxygen atoms bond easily with the oxygen atom in chlorine monoxide. This means a single chlorine atom can break up multiple ozone molecules before it disintegrates. CFCs can last 70 to 100 years in the atmosphere before they are naturally broken down. During this time, chlorine atoms repeatedly destroy the ozone layer molecule by molecule. This is why a single chlorine atom can destroy up to 100,000 ozone molecules.
What molecule destroyed the ozone layer? It is chlorine. Correct. Chlorine is the molecule in refrigerant responsible for destroying the ozone layer. Which of the following statement is true? The chlorine atom can only bond once with the oxygen an atom. Chlorine creates carbon monoxide, which destroys the ozone. No. A single chlorine atom can survive in the atmosphere for years. Correct. A single chlorine atom can survive in the atmosphere for years before disintegrating. How many molecules of ozone can 3 molecules of chlorine destroy? How many molecules? Okay, I don't remember this one. I think it's 100. 300. I don't remember this one. Let's submit and see. Correct. 300,000. Correct. 1 molecule of chlorine can destroy 100,000 molecules of the ozone. So 3 molecules of chlorine can destroy 3 times that. It will be 300,000
As the
molecules.
ozone layer
Okay,
depletes, more
continue.
ultraviolet radiation is able to pass through the atmosphere. Increased UV radiation causes increase in skin cancer in humans, increase in cataracts in humans, reduced marine life in ocean algae, destruction of immune systems in humans and animals, and reduced plant life and vegetation. Of the previously mentioned impacts of ozone depletion, the most serious threats to humans are increased skin cancer and cataracts. Destruction of the ozone layer also contributes to an increase in ground-level ozone and smog, which can cause respiratory issues in humans, and erratic weather conditions. Ozone depletion poses a great threat to all life on Earth. Because of this, it is not just a national or regional problem, but a global problem. It affects people all over the world.
What does ozone depletion affect? Only those who stay close to the area of the ozone, only those in the United States, only those in the high altitude, people or over. Correct? In which of the following ways does ozone depletion affect humans? Select all that apply. Increase the risk of heart diseases, risk of skin cancer, increase of risk of, yeah, all this. Is that incorrect? Please try again. Try again. Results, I think incorrect. The ozone is debated. There is not enough ozone present observation and reflect harmful UV rays from the sun. This increased the risk of skin cancer and cataracts in human. Okay, so which of the following are affects the ozone depletion? It's increasing toxicity. Which of the following are effect of ozone depletion? Okay, this increasing toxicity in the ocean, no, increasing acidity in the air, decreasing crop yields, increasing acidity in air, increasing toxicity, acidity in air. So correct, it's increasing toxicity. Incorrect. Oh, decreasing crop yield is an effect of ozone depletion. Oh, which of the following are effect of ozone depletion? Threat to wild and marine life. Man-made structure can be damaged. Okay, cars will be affected. Increasing invasive plants spice. Okay, man-made structure can be damaged. Oh, increasing invasing of planting. Incorrect. Ozone depletion also affect animal on
In the
land and sea.
mid-1970s, scientists discovered that large amounts of chlorine in the stratosphere were destroying the ozone layer. Before then, it was believed that natural occurrences, such as volcanic eruptions, were to blame for the rise in chlorine in the atmosphere. However, it was now determined that this chlorine came from human-made gases. Volcanic activity naturally releases chlorine into the atmosphere. But according to air samples taken from the stratosphere above volcanoes, only a small amount of this chlorine makes it up to the ozone layer. Most of the volcanic chlorine stays on ground level. Air samples taken in the stratosphere provide the strongest evidence that it is refrigerant chemicals that are destroying the ozone. Air samples of the stratosphere contain significantly increased amounts of CFCs and HCFCs, as well as chlorine monoxide. As we discussed, the basic chemical reaction involves a chlorine atom reacting with an ozone molecule, breaking it down into an oxygen and a chlorine monoxide. The ClO then reacts with an oxygen, releasing the chlorine back into the stratosphere to continue the cycle of ozone destruction. These samples match with the increased use and emissions of refrigerant chemicals over the same time period.
Is there evidence that refrigerants are in the stratosphere? Yes, correct. Stratosphere is air samples confirming that refrigerants such as CFC and HCFC make it to stratosphere where they destroy ozone. Do natural events like volcanic eruption contribute in chlorine in the stratosphere? Yes, chlorine in the stratosphere is primarily from natural sources such as volcanoes. Yes, chlorine can come from natural sources such as volcanic eruption, but they are not the primary source. Yeah. Correct. What is the primary source of chlorine in the stratosphere? Volcanoes, natural sources such as earthquake, emission of refrigerant chemicals such as CF. Emission.
In conclusion,
Okay.
ozone depletion is due to chlorine-containing refrigerants and gases in the atmosphere such as CFCs and HCFCs. The most harmful types of refrigerants are CFCs. Evidence of ozone depletion can be found in air samples from the stratosphere. Because of the importance of ozone to sustaining life on Earth, ozone depletion is a global problem.
Okay. We will finish core ozone. This is the third one. This is a core ozone quiz. Okay. We'll finish this later. Okay, this 14 question. Okay. Do natural events like volcanic eruption contribute to chloride in the stratosphere? Yes. Chlorine can come from natural sources such as volcanic, but they are not the primary source. Okay. Ground level ozone is what absorbs and reflects harmful UV rays from sun. False. In which of the following ways does ozone depletion affect humans? Select. Increase the risk of heart diseases, increase risk of skin cancer, increase risk of nose cancer, increase risk of cataracts. Okay, so this skin cancer and cataracts. Is there is evidence that the refrigerants are in stratosphere? Yeah, same question that we answered before. Question number 5. Which of the following statement is true is about chlorine? Chlorine atom can only be bound once with an oxygen atom. A single chlorine atom can survive in the atmosphere for years. Yeah. Ozone has 3 atoms of oxygen. The majority of ozone is located in the troposphere. False. How many molecules of ozone can 3 molecules of chlorine destroy? It is 30,000. What is the major function of ozone in the stratosphere? What is the major function of ozone in the stratosphere? Absorb and reflect UV rays from sun. What is the primary source of chlorine in the stratosphere? Volcanoes, natural sources such as earthquake, emission of refrigerant. Yeah, it's emission of refrigerant. What molecule destroys the ozone layer? Carbon, chlorine. Which of the following are effects of ozone depletion? Increasing toxicity in ocean, increasing acidity in the air, decreasing the crop yield, increasing the crop yield. What overall effect of the ozone depletion is increasing acidity in air? I don't know if this one correct or not. Which refrigerant chemical are responsible for destruction of ozone layer? CFC and HCFC. What does ozone depletion affect? People who close to the area with a lot of ozone, people in the United States, people in all over the world. Finish that then. Okay. submit. Now it is 9.29 of 10. All the answer is correct except this one. I think there is one here. Yeah, I was thinking this one is correct or not. Which of the following are affects ozone depletion? It is, your answer is incorrect. Decreasing crop yields. Decreasing crop yields is the correct answer. Okay, so we done. Finish review. Okay, let's go back to core ozone. We finish all. Let's check the course. Okay, so we finished this study guide and we finished the core introduction. Okay, we finish the introduction and we finish this core is ozone. Okay, the next time we will continue, okay, the course one by one, but in another video.